This is example 3 of section 3.5. We're on page 44 of the notes. So we're working with the law of sines, and we learned that there's 3 different possibilities of triangles. So we can either have 0 triangles, 1 triangle, or 2 triangles. So this example is one of those 3 cases. So we want to solve a triangle ABC where angle A is 45 degrees. A, so side A, is 7 root 2, and B, side B, has a length of 7. So first let's just draw a triangle. So just draw it, and we'll write down what's given. So angle A is given to be 45 degrees. Side A, so directly across from that, is given to be 7 rad 2 in length. And then we have angle B, side B, angle C, side C. So let's see, we did angle A is 45, we did side A is 7 rad 2, and then side B is 7. All right, so we're always given 3 pieces of information. This happens to be SSA because we're given a side, then an angle. And SSA is the one that can bite you. Remember, like the snake? And that's because of the 3 different possible cases. The 0 triangle, 1 unique triangle, or 2 possible triangles that fit this condition. So you see that we have alternating or corresponding angle and side. We have an angle and a corresponding side. So that tells us we can use the sine property. So let's go ahead and do that. The sine property says we have sine of 45 degrees over 7 root 2 equals, now we want to choose B and angle B because that's the only other piece of information that we're given. So we'll write in sine of angle B over 7. That alone is the law of sines, and now we can just solve using algebra skills to get the angle B. So first let's cross multiply. Boom, boom. So I'll multiply 7 rad 2 and sine of B. So 7 rad 2 sine of B is equal to 7 sine of 45 degrees. Then I'll divide both sides by 7 rad 2. Divide both sides, 7 rad 2. It'll cancel. And I'll be left with sine of B is, actually even the 7's cancel. So I'll just have sine of 45 degrees over rad 2. And sine of 45 degrees is something we know from the unit circle. We could think of it as root 2 over 2 or 1 over root 2. In this case, I'm just going to use 1 over root 2. Either one would work. Okay, so again, sine of 45 degrees, I just turned it into being 1 over root 2. If we simplify this is a fraction on top of a fraction. So we can say, hey, this is really rad 2 over 1. So we'll have the top, 1 over rad 2, times the reciprocal of the bottom. So now the 1's on top, rad 2's on the bottom. 1 times 1 is 1. Rad 2 times rad 2 is just 2. So we get that sine of B is equal to 1/2. Now from our notes at the top of this page, it says that if sine of our missing angle is less than 1, then we want to check two possible angles. So there might be two possible B angles that work for this setup. So let's try that. Okay, oops, that's still a highlighter. There we go. So from this equation, we're going to split up and say, okay, if sine of B is 1/2, if I take inverse sine of both sides, I can show my work here, but I'm just going to take inverse sine of both sides. So inverse sine of B and inverse sine of 1/2. Okay, so we know the properties of inverse functions. These will undo each other. So we're left with B is equal to inverse sine of 1/2. So keep in mind that when we're doing inverse sine, sine is only on this half of the unit circle. So inverse sine, that's the y value of 1/2 within this area. That's going to be over here. That's going to be pi over 6. So my first option of a b value, so I'll label it b sub 1 as my first option, which since we're given the problem in degrees, we should actually probably think of it as degrees. So let's use that the y value within this area, being 1/2, occurs at 30 degrees. So let's go ahead and say b sub 1 is 30 degrees. Cool. Come over to the other side, directly across, that y value is going to be the same over here. So to find that angle, we're going to do 180, so all the way, minus the 30 degrees. So minus this little piece to give us that angle. So b sub 2 is going to be 180 degrees minus 30 degrees, which is 150 degrees. Okay, so we have two possible angles that satisfy this equation. There's obviously a ton more because if you just add 2 pi to each of those, we're going to get infinitely many angles. But right now we're trying to make a triangle, so it makes sense that we only want angles between 0 and 180 degrees. So that's why we're going to stick with 30 degrees and 150 degrees. Those are the two angles that have the y value 1/2. Okay. So now we want to say, okay, we have two possible places on the unit circle that give us sine being 1/2. Let's make sure that both of those possible angles work with our given information. So we're going to go over to b sub 1 and make sure that the given angle, which is A, we're just going to check our work, or check the angle, the given angle, which is 45 degrees. All right, that given angle over here is 45 degrees. We want to make sure that plus our optional, so plus our optional b sub 1, which is 30 degrees. We want to make sure it's less than 180 degrees because all three angles have to add up to 180. So we want to make sure that's possible. So 45 degrees plus 30 degrees, that's 75 degrees. That's less than 180 degrees, so we're good. That can be a triangle. Now similarly, we want to check our other possible b value. So we're going to add our original given angle, which was A, 45 degrees, plus 150 degrees. If we add that, it's 195 degrees. That's way too big. So only two of our angles that we're trying to say are angles of a triangle add up to be 195 degrees. That's not possible, because all three angles should add up to 180. And in this case, we only have two angles adding up to more than 180. So that tells us there's only one possible triangle, because this other angle doesn't work with the given conditions. Okay, so now that we know there's only one triangle, let's go ahead and finish solving it. So we know now that our angle B is 30 degrees. And as we were mentioning, all three angles of a triangle add to 180. So angle C is going to be equal to 180 degrees minus 45 degrees minus 30 degrees. Okay, so all three of our angles are answered. Now we just need to find our side length C. So to do that, we'll use the law of sines again. So we'll start off with sine of 105 degrees divided by C. And then we can use either of the other two pairs in this case because neither one of them are rounded. So we can actually use sine of 30 degrees divided by 7. Again, we'll cross multiply. So we're going to get, let's see, C sine of 30 degrees is equal to 7 sine of 105 degrees. Next, we can divide both sides by sine of 30 degrees. Now we know sine of 30 degrees is 1/2. So we can either enter 1/2 right now into our equation, or we can plug the whole thing into our calculator. So we'll get C is equal to, so that gives me 13.52296, etc. We'll just stick with 13.52. So on our triangle, we'll write out 13.52. 13.52.